So hi everyone, I'm Marina Kogan, and this is my work together with Leysia Palen on Twitter conversations in crisis environments. Sense-making activities, which can consist of communication, information seeking, and coordination, are essential in crisis. Specifically, White shows that constant communication is a central aspect of sense-making as it contributes to situational awareness. So social media conversations in crisis are important to study as they provide insight into sense-making activities of those affected. However, social media analysis in crisis informatics and beyond has relied on analyzing individual tweets. The data are collected, stored, and sampled in ways that reinforce tweets as individual units of analysis. Even the work that has attempted to look at social media conversationally still focuses on pairs of tweets as unit of analysis. Still, this represents progress towards fuller treatment of social media data. So in this work, we push beyond the tyranny of the tweet as the primary unit of analysis, as the social media users themselves view their tweets conversationally and discursively. So the contribution of this work is threefold. Position social media conversations as the unit of analysis, so move towards fuller treatment of social media interactivity. Offer computational methods for making social media conversations analytically available and analyzing them at scale. And finally, use these techniques to gain insight into sense-making activities in crisis. We studied this in context of the 2012 Hurricane Sandy. As you can see, Sandy was a devastating event with 162 deaths and 65 billion in damages. It was also the most tweeted natural disaster to date at the time. So here's an example of Sandy-related Twitter conversations to give you a glimpse. This conversation begins with Susan Rubin after landfall discussing a blog post about managing damaged belongings. 3 hours later, Mothach makes an observation about people scavenging damaged appliances left curbside. Another 3 hours later, Silly Raven, a third conversational participant, chimes in about the unspoken etiquette of damaged appliances. After a long break of 19 hours, Mothach responds about the implied etiquette not being widely accepted. And finally, 2 hours later, we see a rapid back and forth, minutes apart, between Mothach and Silly Raven about the placement of these particular damaged appliances. So this conversation demonstrates several features we examine in this work. We see branching that happens between conversationalists, in this case, at the very first turn take. We see long breaks between rapid bursts of activity, with important events related to the conversation seemingly happening in between. Finally, we see prompting and discussion about what to do in a situation that many here may not know much about, that people aren't familiar with the situation, giving a glimpse into their sense-making activities. So clearly looking at the whole conversations, as opposed to isolated tweets, opens up much more nuanced and interesting view of the activity. But how do we extract those conversations for analysis? Let me briefly walk you through that. First, we collected data using streaming Twitter API and using these keywords. We then defined a geographic bounded box for the region most affected by Sandy. Tweets within that bounded box were considered local tweets to the event and comprised local keyword data set. We then identified the users who produced at least one local tweet in the time period of interest, and then collected all their tweets using REST API. This comprises a local contextual data set. And gathering all these contextual tweets is important because prior research shows that many disaster-related tweets did not contain any keywords, often instead referencing the earlier tweets. From there, we further narrowed the data set to local replies, and even further to local replies that respond to the local original tweets. Combined with those originals, this produced our local conversational data set. This process ensures that the conversations we construct are among the locals who had some Sandy-related activity. Finally, we divided the data set into 4 10-day time periods, before, during, after, and long after. And we chose those time frames based on our knowledge of socio-behavioral phenomenon in respect to disaster stages. We used network analysis methods to analyze and extract the often complicated conversational structure from the tweet reply pairs. Specifically, we constructed a directed acyclic graph from the tweets and replies. In this setup, each conversation can constitute a separate connected component in the directed acyclic graph. So here's the distribution of the tweets and conversations across the 4 time periods. And you can see that the during has the highest level of activity. In the rest of the talk, I will discuss our findings as they relate to the temporality of conversations, the relational structure of the reply network, the composition of conversation participants, and the content of the conversations. First, let's look at temporal dimensions. Following the technique used by Geiger and Hafeker to determine the length of characteristic work sessions in Wikipedia, we calculated the time span elapsed between each pair of users' consecutive tweets. This intertweet time has a trimodal distribution. This suggests that the time spans between tweets have 3 characteristic lengths. The first peak is centered around 3 minutes, corresponding to rapid-fire tweeting, when users actively engaged with Twitter content and participate very rapidly. The second peak centers around 2 hours, corresponding to the periodic check-ins throughout the day, when breaks may take hours. And the last peak is centered around 16 hours, corresponding to diurnal patterns, where some users check on their feed in the beginning and end of day. Outgoing replies display similar patterns in terms of where the peaks are located, so it suggests that tweeting as a temporal practice fits well into the tweeting practice overall. But the many more outgoing replies happen within the diurnal pattern, so many users take longer between replying to tweets than just tweeting, potentially lingering for a variety of reasons. The tweet reply time distribution also supports the lingering hypothesis. You can see that this distribution is much more long-tailed, and the single mode suggests that there's a prevalent behavior, but the long tail suggests that it's very variable. So it seems that the timing of replies is better explained by the Twitter's own practices, as opposed to the arrival time of the original tweet. So, as I mentioned, the Twitter replying fits into existing temporal patterns, but users tend to linger longer with replying than tweeting overall. The lingering becomes even more apparent across time slices. The time between tweet and its reply is longer in during and long after than in before period. Here's an example of unrushed conversation that takes place in a high emergency period between 3 people. It starts with TC Brader checking up on their out-of-town visitors in this chaotic environment post-landfall. One of them responds 4 hours later with some more general updates. But the other one takes 12 hours to respond, likely being busy with volunteering effort. So the whole exchange accumulates to 17 hours. Looking at the conversation level patterns, we can see that the whole conversations are also longer, although it's only significant for the long after. So the social context of high emergency and post-disaster recovery drive more people into taking longer to reply to tweets, slowing down their exchanges between Twitterers. And their conversations tend to be longer as well. Who responded to whom is also an important aspect of conversations. So let's look at the relationality of reply network. For each time slice, we constructed a directed network where 2 local users were connected if one replied to the other. The relative size of the largest connected component is a proxy for how densely interconnected the network is. These networks don't have large components, but the during one is significantly larger than the others, except encapsulating 30% of all the activity. This is lower than in most social networks, but it's still impressive. So that means that 1/3 of the population that was active in the during period actually was interconnected just through their conversations. And the much more interconnected nature of the during network suggests that the sense-making of Twitterers in disaster connects the parts of the network that do not normally talk to each other. We can see that in the short after, there's also somewhat larger interconnected component, which suggests that some of this interactivity persists into recovery and speaks to the sociology of disaster concerned with community resilience. So this sense-making work of Twitterers in disaster connects the parts of the network that don't normally talk to each other. And some of this persists into the recovery. Reciprocity here is the proportion of outgoing replies that are reciprocated. It is high for all time periods, but it's actually lowest in the during period. The reciprocity here is dampened by frequently replying to the official estate accounts, which tend not to reciprocate in conversations. Mixing patterns refer to what types of nodes tend to connect to each other. Here, most interesting is in degree assertivity, how often users with many others replying to them tend to connect to each other. The before and long after assertivity is positive, but then the during and after networks are disassociative. This suggests that in crisis, people are less likely to connect to others with similar numbers of conversational partners. And since this is a proxy for popularity, it means that people are less likely to connect with others with similar levels of popularity. And so their communication becomes less homogeneous in disaster. Overall, the network structure suggests that in crisis, users connected with more diverse Twitter community, both in terms of the number of conversation partners and their status, such as the official government sources. Next, let's consider the composition of participants in these online conversations. A surprising 25% of conversations consist of one user replying to their own tweets. These are mostly two tweet sequences where the second is a quick correction for a small mistake or a typo in the first. But in some cases, Twitterers reply to their own tweet to elaborate or expand a point. And these monologues might take any amount of time. Like in this conversation, where NSU NYC observes the intense traffic and includes a photo. Over an hour later, she follows up with a realization that the traffic is related to the post-hurricane gas shortage. Two-person conversations that we typically associate with conversations comprise 73% of local discussions. And only 2% are made up of exchanges involving more than two persons, two people. So let's consider how this has affected the temporality of conversations. Both dialogues and group discussions are considerably slower than monologues. This makes sense, as the Twitterers don't need to wait for another party to reply. This result points to the difference between the individual and social behavior. Group discussions are especially slow, like in this conversation where Mandy Ado starts by expressing concern with the cell service in the mid-afternoon. Guardian Lily responds 6 hours later, concurring the problem. And by the time Martha S. Andrews responds with humor, which is a common coping mechanism in disaster, it is almost midnight. If we consider how conversations changed over time, we see twice as many group conversations in the during as in other periods. So it seems that coordination needs of sense-making in high emergency period prompt more group activity. And since the group discussions tend to be slower and longer than monologues and dialogues, this high presence and during likely contributes to slowing down the conversations in that period. Finally, let's consider how the content of the conversation factors into the practices. We coded all the conversations as either on or off topic. So about 35% of local conversations are about Sandy. They're highly concentrated in the during period where they comprise 72%, and they tend to be considerably slower and longer than off-topic conversations. So the discussions of the hurricane then contributes to slowing down the conversation in during. Analyzing conversations qualitatively, we see that in crisis, people tend to check in more broadly across their local network, even explicitly asking or offering help in the broadcast fashion. Like here, Ken TY is asking his entire network for information about volunteering locations in some of the most affected areas. Note the early hours of the morning in this post. Because the request isn't aimed at anyone in particular, the first reply takes about 8 hours to arrive, but points to a website with useful actionable information. With another follow-up by the same user arriving in a couple more hours. So to sum up, through at-scale analysis of Twitter conversations local to disaster, we found that conversations in crisis had a broader reach in terms of number of participants, types of participants, including their status, as with popular and government media sources, and their connectivity patterns. This broader reach contributed to the slower and longer conversations in the during period. While surprising in high-tempo, high-pressure environments in crisis, such slowing down is actually well motivated by sense-making literature. Finally, we found evidence that points towards an intriguing possibility that people use Twitter as a log to which they return when time permits, with their reply notifications serving as reminders. This is potentially in opposition to, or at least in addition to, the dominant view of Twitter as a real-time sensor. And with this, I'd like to thank you for your time, and I'd be happy to take questions. Also, I wanted to add, as a new faculty, I'm looking for students, so if anybody's interested in this kind of work, reach out.
Okay. Please don't forget to state your name and affiliation. Anybody have any questions?
Hi, Moore Naman from Cornell Tech. So I want to, first of all, two questions maybe.
Mm-hmm.
One is, were there types of conversation that show different temporal dynamics than other types? You talked a little bit about types of conversations that show different temporal dynamics than others. So I can imagine during, for example, there will be requests for help, there will be general statements, there will be direct requests for help.
So the content analysis, we did only look in terms of whether it's on topic or not, because we did collect all the contextual information, so not just conversations about Sandy, but also others that were accompanying them. So the only qualitative analysis was in terms of whether the conversations were about Sandy or not. Did not do any systematic analysis within those of what kind of typology was there, but looking through the conversations, because I had to code them all as on topic, there seems to be more question answering and on topic that takes a while, sometimes especially when people are reaching out to official sources, which they don't always respond in a timely manner, especially in this kind of environment. And this practice of reaching out to the broader network seems to have a strong relationship with the temporality in terms of kind of not addressing the question to anybody in particular, but just reaching for help more broadly.
And the second question is, since you're looking for students, say a new student comes to your lab and collects a similar data for more recent or future such event, how do you expect the trends that you found to change in a new data collection after several years with Twitter changes?
Well, I mean, first of all, the data will be different because there's more words in a tweet. There's much more data in the tweet text itself. So I expect the content to be somewhat more expressive in that sense. Also, now that we have these results, in some way, we'd be looking more for sort of classical conversational analysis patterns. So how do people address each other? How they elicit a response? And those, so I guess it's not so much about the data itself, but the methods that I'm hoping to apply to it, because this was just kind of a first step at looking at this conversationally, but now that we have these results, I think it would be really interesting to dig further into that. The data might be also different in the sense of, well, we know about misinformation on Twitter historically, but I wonder if current political climate also is affecting even this kind of data, even though it's not necessarily politically motivated. I've seen examples in the recent hurricanes where there were fake tweets about hurricane paths, and then the official sources had to correct that. So I think we might expect more misinformation in the more recent data. Thank you.
Any other questions? I'm going to ask my question then.
Okay.
What other events or topics do you think would have a conversational approach like this on Twitter? Do you think it's any conversation, or is it limited to specific ones?
Well, so I think there's conversational activity happening everywhere with respect to different topics, but I think the sort of high-tempo crisis-related events just accumulate such a large amount of data because of the phenomenon of convergence. People kind of congregated around these events, whether on the ground or on digital media, that it would allow us to produce large enough data sets to be able to see these patterns. Because if you remember the method slides, data set got pared down so much to be able to kind of get to these local conversations that in the end it was on the order of 5,000 conversations when we started with millions of tweets. So I think the disaster or crisis disruption kind of context is especially fruitful for conversational analysis because partly it produces so much data.
All right, thank you, and thank you everybody for joining us for this session. Up next is a video showcase.